Hello folks, today I'm going to be doing a review of the Forney Easy Weld 125FC welder. It's sometimes also called the Forney Easy Weld 299. I do see catalog number 299 right on the front panel here, and I see it listed a couple other places, and sometimes that's how it'll come up under a search. But it's either the Easy Weld 125FC or the Easy Weld 299. Now this is a 120 volt flux core only wire feed welder. So this does not do MIG. There's no way to run gas with this welder. It's flux core only. And it's a very inexpensive machine. I got mine on Amazon. Prices fluctuate a lot on Amazon, but at the time I purchased mine, I got it for under $150. So it's very inexpensive as far as welders go. I haven't used it yet. There are definitely some concessions you give up for that low price. But we'll get to that as we get there. First, I'm going to start out by just kind of going over my first impressions after taking it out of the box, what the welder comes with, and then we'll fire it up, do some welding with it, and see how it does. Alright, so let's take a look at what comes in the box with the welder. It does come with a starter spool of flux core wire, but as you can see, there's actually very little wire on this spool. I mean, it really truly is a starter wire. It doesn't weigh much at all. I'm pretty sure it's going to be under a pound of wire on that. So it'll be enough to get you going, but it's not going to be enough to do a lot. That is what comes with a welder normally. I did get a package deal on Amazon, which was actually less expensive than the welder by itself for some reason. And it actually did come with a full roll of the Forney, it says MIG wire, but it's actually gas shielded flux core. And that's a full 2-pound spool. So that's pretty good value there that comes with it. But normally if you get just the welder, it does come with a spool of wire, but it's going to be a very small starter spool, so just something to be aware of. It does come with a little combination chipping hammer and wire brush. Very cheap, basic kind of a thing. The hammer end is literally just a little plug of metal stuck down into the plastic, and the wire brush, the bristles are pretty widely spaced, so pretty basic, pretty cheap thing, but it does come with it. It comes with this bag, which has 2 spare contact tips, both for 030 wire, and it does come with these 2 screws. And what those screws are actually for, it also comes with these 2 handle extensions that actually set on top of the welder. It comes with 2 of them, one for each side, and that just provides a second handle that would be on either side of the welder, so you could use 2 hands to pick it up versus using the integrated single handle. And those screws are to attach this to the top. It does come with a package of manuals in a couple of different languages, looks like 3 different languages, as well as a quick start guide. Also comes with a warranty registration card in the box. The ground clamp is pretty basic. It's got a pretty stiff spring to it. It is just stamped steel. The jaws do have this little strap of copper that goes between the two, but it's just kind of loose in there, and there's not, there aren't real good solid copper jaws here, so not really unexpected at this price range, but it is a fairly cheap ground clamp. The power cord is nothing special, just a standard 120 volt power cord. I did just want to point out, though, one thing interesting about it is that it is actually attached to the front of the welder along with the rest of the cords, unlike most welders where it would be attached in the back. And the reason I think that's of note is because all of these cords are 6 foot. So you have a 6-foot power cord, 6-foot ground cable, and 6-foot MIG lead. And actually the lead itself is a little bit less than 6 foot. It's actually closer to 5. But if you measure from the welder out to the very tip of the MIG gun, you actually get 6 feet. So from the front of the welder to where the cable attaches to the gun is only about 5 feet. But normally if you're using this away from a wall, the front of the welder would be kind of facing your work, and the back of the welder would be facing the outlet where you have it plugged in. And that would give you an extra couple feet, or whatever the length of the welder is, distance from the wall. But with this welder, with the power cord coming out the front, that's going to have to come off the side to go to your outlet, and then the MIG gun will go from there. So just something to keep in mind. You generally don't want to use an extension cord with the welder unless you absolutely have to. And if you do use one, you want to use as thick of a gauge as possible. But just something to keep in mind. You're a little bit more likely to run into situations where you need one with this welder than some others, because you only have a 6-foot power cord and it comes out of the front of the welder. Now here's the gun itself. Without having used it, I'll just say the trigger is a little stiff. I'm sure it'll work okay, but it's a little bit stiffer than most. Also, I noticed the MIG gun has a fairly straight profile to the neck here. Most of them kind of curve and angle down a lot more. That means that if you're working on a bench, you're going to have to be holding the gun a lot more vertical. You know, some may like that, some not. It's just something to note. It does have a screw-on nozzle here, but the included nozzle is more of a MIG nozzles type that's designed to allow gas flow. With this being a flux core only welder, it would have been nice if it had kind of more of a flux core nozzle on it that was just a small tapered nozzle that protected these threads and protected this stuff a little bit more, but also more than anything, just you don't need this extra size and bulk when you're running flux core because you don't need to allow gas to pass. So it's just a little bit more convenient to have the smaller flux core nozzles on them. And it does come with one installed contact tip, also 030. So total with the machine, you get 3 contact tips. So here we have the front panel of the welder. We do have our knob for adjusting wire feed speed, and it is an infinitely variable knob. Once I get to using it, I'll see how well that works, but it is smooth, infinitely variable. You do have an over temp light here, power on-off switch, and here you have your voltage selection switch. It's just a 2-position switch. You have sheet metal, which is the lower setting, and then you have thin plate, which is the higher setting. So basically you can think of it as low and high, but they just call it out as sheet metal and thin plate. Here we have the side of the welder where you access the wire feed and the wire spools. You just pull down this little latch and it actually drops open rather than a lot of them where they lift up. So this one just drops right open and out of the way. You do have an overcurrent breaker here. Here is the wire feed mechanism. It is mostly plastic, as you might expect for this price. It does have adjustable drive tension here. And then when you fold this down, this isn't spring loaded or anything, and it doesn't even come up far enough to stay. But with this lifted up, you can see it does have a ball bearing roller here. And then the wire, the drive roller is down on the bottom here. To remove that drive roller or change the wire size, you actually just turn this little knob and it just pulls straight out. And then you can pull the roller off of that shaft and flip it over. The roller does have notches for 030 and another one for 035 wire. So you can run 035 wire with this machine, although in the manual it does recommend to use only 030. We'll see how well it does once we get to welding, but it doesn't, it's definitely lower quality than most of the other welders I've used, as would be expected for the price, but just know that you're kind of getting what you pay for. You're not getting a lot more than what you pay for here. The wire spool is pretty simple. There's a knob here that you can loosen or remove and has a spring, and then this little collar, so you can slip the wire on here, slip the collar on, and then the spring and the knob, and then just tighten it down. And you can adjust the tension with this knob here. One thing to note, this shaft is kind of D-shaped, and that keeps this washer from being able to spin as the drive roll spins, and that's nice because it doesn't kind of want to give this a tendency to adjust as the spool is running out. But it also does make this knob a little bit fiddly to get started sometimes, because you have to be real conscious that you don't cross thread it, because it'll kind of want to go on sideways like that right there. It's kind of wanting to cross thread, so you have to be real conscious of how you're getting that started so you don't cross thread it. Just something to be aware of. It does have a settings chart on the inside of the door here. It's very simple just because of the limited settings this machine does have. It just shows 3 settings for different types of steel on the lower voltage setting, the sheet metal setting, and then 3 settings for thicker steel on the thin plate setting. And it's kind of interesting to note that this chart only goes up to 3/16 inch thick material, even though in the spec sheet it does actually rate the machine as capable of up to 1/4 inch. But it does show wire feed speed setting of 5 for 3/16 material, and the setting actually does go up to 10, so it'll be kind of interesting to see how close those settings work out. So there's kind of an overall look and some quick thoughts on it. Overall, I think the build quality is okay. It's okay for the money, but it's not fantastic. So far, nothing majorly jumps out at me as an issue, though there are a few little quirks and cheaper components which you might expect for the lower cost. But it could be some things that you might want to be aware of if you're considering this welder. Now, one of the big drawbacks of this welder, and one of the reasons I think it costs a lot less than, say, the cheapest Lincoln or something like that, is the fact that this is actually an AC output welder. So most MIG or flux core wire feed welders, they're actually going to rectify the AC from the wall and turn it into DC output. And then you have the ability to select either wire, what they call electrode, be negative, or electrode positive. And then that would make the work clamp either negative or positive depending on how you have that polarity set. With AC output, it's alternating, so it's switching back and forth 60 times a second. So what that means is you're only going to be running the optimal polarity for flux core 50% of the time. Now this is a cheaper way to do it because all you have to have is a big transformer in there and some circuitry to change the voltage and the wire feed speed, but you don't have to actually have a rectification bridge in there, so you don't actually have to change the voltage over to DC. So it's a cheaper way to do it, but you're going to get a rougher arc out of this, you're going to get a lot more spatter, and potentially a little bit reduced penetration just because that current is flopping back and forth, and it's not going to be optimal. So just be aware that is one of the big concessions for the price that this welder makes. It is definitely something to be aware of if you're getting this welder. It is an AC output welder, so it's not going to be as smooth and you're not going to get as good welds as you would with a DC output welder. So now I'll do some welding with it and see what we get out of it. I will use the included wire, but just to see if there is any difference, I also have some Lincoln Inner Shield 211, some NR211MP here. And I've had good luck with this wire in the past, so I'll try some of this in it too just to see if there's any difference. And all of these wires are 030 wire. So let's fire it up and see what we can do. Alright, so I just got done doing some welding with the machine. I have a few of the joints that I made just laying here on the table. It does weld okay. Despite being AC, you can get a pretty decent looking bead, albeit with quite a bit of spatter. A few things I did note. One, the short cords and the power cord coming out of the front definitely does cause an issue. You really can't get very far from the wall, and then with the short ground and gun leads, you really can't get very far from the welder either. So you're really going to almost have to use this with an extension cord some of the time. If you do use an extension cord with it, just use as heavy an extension cord as you have. The power cord on the machine is actually only a 16 gauge wire. It's fairly short, so maybe not a huge issue, but it's fairly thin wire on the power cord to begin with, so just don't add any more extension cord length than you really have to. Initially, I did get some erratic feeding. The wire kind of wanted to feed it at an erratic speed, and I think a lot of it was due to the fact that the first few layers of this included wire weren't very straight. They were they weren't wound on the roll very smooth, so they kind of came out rough looking, and it just kind of made it really stiff feeding through the liner. It fed a little bit odd at first. I had to really crank the tension down pretty hard to get it to feed smoothly. But I did find that after a little while of welding, it did get a little bit better, and I think that was due to this wire just kind of the more inner layers of it were smoother, wound more evenly, and also with the other wires that I used that were just smoother on the roll to begin with, it seemed to feed a lot better. I didn't have the nozzle on the gun most of the time. Since it's not a MIG gun, there's no gas ports that you have to protect or anything like that, so there really isn't a big need for a nozzle at all, just because the tip is recessed into the nozzle a little bit, and the nozzle kind of gets in the way of being able to see the puddle as well as you'd like, and depending on the angle and stuff. I just left it off for most of the welding, and it worked fine. I wouldn't have any issue of just leaving it off and never worrying about it. The cheap ground clamp was a little bit annoying some of the time, just because of the angle of the jaws you can see here. It's really only going to clamp straight and get very much contact area if you're on something really thick. But most of the time, just clamp to a thin piece of the table or something. You can actually see where it was kind of arcing out a couple of times. You have this little burn mark there, but then the rest of it is just all soot covered because it really wasn't touching anything. The other side kind of the same way, just all covered with soot. So just something to note that this ground clamp is pretty cheap, and you want to make sure you get on something really nice and clean, and you maybe even wiggle it around a little bit, and just do everything you can to make sure you got a really good solid connection with this clamp, because you're kind of starting from a disadvantage right off the bat, just because of the design of those jaws. I'm sure the AC output did play into this a little bit, but the welder did seem to be a little bit underpowered. Now I know it's just a 120 volt, so you have to have limited expectations, but I've used other 120 volt flux core welders that did seem like they had more power and more heat than this, although those were DC output welders. So like I said, I think that may have had something to do with it. On 1/8 inch material, it did seem to do okay. You can see here, it lays in a pretty smooth bead, not too bad at all. I don't know how well it shows up here, but you can see that there's a decent amount of spatter here, and the spatter is kind of the larger beads that are a little bit harder to get off. This is maybe one of the cleaner joints, but you can see on something like this one here, you can see quite a bit of spatter, and that's just largely from the AC operation. Just you're going to get a little bit more spatter. But again, with the 1/8 inch joints, you can see they lay in there pretty good, pretty smooth, pretty flat bead profile, not too bad. Here's one where I did just a little bit of a weave. So on 1/8 inch material, I think it does okay. This one's kind of rough because I had to stop and start. But even on 1/8 inch material, when you first start the arc, you do kind of have to hang around a little bit before it gets a good puddle going. And then it's really easy to outrun the puddle. You got to go really slow. And don't really allow that puddle to wet out, because it just seems like you're pretty limited on heat. And you can see even on 1/8 inch material, this weld was actually done at the setting for 1/8 of an inch. And you might be able to tell versus that other weld, it's a lot taller bead profile. You have kind of a valley at the toes of the weld, and like I said, it was really hard to get the flux out of there, or the slag. But it just seemed like it was going in a little cold, even on this 1/8 inch material, and this was set for 1/8 inch material on that weld. And then on this side, here's one where the flux came out of it a little bit better, but you can see there's a little bit of a valley there. So it's kind of keeping kind of a crowned bead. Just seemed a little cold, and this was run on the setting for 1/8 of an inch material. And to get a smoother, flatter bead like this one, I actually had to run it at a higher setting. I actually had to turn the wire feed speed up to get a little bit more heat out of it in order to get it to lay down flatter like this. And then on the 3/16 material, you can see just a little bit lumpier weld, because the weld was just cooling so fast as you move along that it's just even harder to be really smooth and even. And again, you see this really tall bead profile with this big valley down here at both sides. And then I stopped about here to kind of reposition, and when I started again, you can see when it started, the weld was just kind of laying on top of the other weld. It really wasn't wetting out at all. You have a big ditch here and there, and then as it started to heat up and I started to move, it did start to wet out a little bit better again. But even still, we have this just a real tall bead. And on this side, on this one, the slag was a lot harder to clean down in that crack, but again, just kind of a tall bead, not really wetting out very well. And on the 1/4 inch material, same story, but even worse. You can see here just a very tall, kind of a convex bead, very narrow, big valley down here at the edges. And on the other side, a little bit different setting, but same kind of a thing. I tried with the maximum wire feed speed here, and it was just really this real tall crown weld, and these edges are just totally full of slag, so it's hard to clean these up enough to really tell, but this is just a really deep valley here. So I tried with a little bit lower wire feed speed, thinking, well, maybe it's just doesn't have enough heat to melt it that way, and it got me a smaller bead, but still just as crowned with still just as little wetting out action. So I am going to cut and etch a few of these welds and just kind of see what penetration I actually did get. But just based on how it was running and based on just the visual results afterwards, I would call this a 1/8 inch and thinner material welder. On some of the specs I've seen, it rated for up to 1/4 inch, and on the door chart, it only lists settings for up to 3/16 of an inch. But honestly, other than just for really non-critical, non-structural stuff, I wouldn't use it for even 3/16. I would say 1/8 inch and down. All right, so here's the first 1/8 inch joint. And you can see here, there's actually a little bit of a pocket right down there at the root. There's actually from here over, there's really no penetration. So very little penetration down into the root of the joint. On the vertical section and on the base, there is some tie-in. Not a lot of lack of fusion per se, but very shallow penetration. So while the weld isn't just kind of laying on top of the metal, it does seem to be sort of tied in along both edges of the weld. Very little penetration. So as you can see, even on the 1/8 inch material, and this is what that weld looks like on the face there. So even on the 1/8 inch material, not a lot of penetration on this material out of this welder. All right, here's the cut and etch of another of the pieces of 1/8 inch material. On this side, you can see on the vertical section, I did get a little bit of penetration. On the horizontal piece, this is the different wire, and it was hard to get very much contrast on this cut and etch. But down here at the bottom, you can see little to none. I mean, it's really just laying there. Basically almost no tie-in here. Maybe just a little teeny dab there, maybe a little dab there. But then again, at the root, I mean, again, you can see just a hole there, maybe even a little pocket of slag. So not penetrating down into the root, and very little to no penetration on the bottom here, and only a little bit on this vertical section. Now on this side here, I was actually running the welder at the setting for 1/8 inch material with the included wire. So it's actually a little bit colder yet. And you can see while maybe just a tiny bit of tie-in on the vertical section, not much, but maybe just a tiny bit. But down the root, again, no penetration down into the root, actually a pocket of slag down there. And once again, on this horizontal piece, almost none. Like right there, there's pretty much no fusion. Maybe just a little teeny spot there and a little teeny spot there of fusion, but nothing in the middle. So even on this 1/8 inch material, running at the recommended settings for 1/8 of an inch, very, very little penetration. Now here we have the 3/16 material. Similar story to the 1/8 inch, only even more so. Both of the sides of this joint, and it did cool completely in between these two. So there was no preheating on this part. Both of these joints were welded out with the piece cold. On both the vertical sections, the line isn't perfectly straight. It's just a tiny bit wavy. And right here you can see, just a little bit of a waviness to the line. So on this vertical section where, you're heating the end of the piece rather than the middle of the piece, you did get a teeny bit of tie-in in a couple of places. Very little penetration. And actually not even complete tie-in, but some tie-in. But then here on this horizontal section, just no tie-in at all. Just perfectly straight, flat across on both of these joints. I mean, you can see just a perfectly razor straight line. And then again, as we're seeing with kind of all of the joints, no penetration down into the root, a little pocket of slag. 3/16 material even turned up. Like I said, on these two joints, on the one side I had the wire feed speed almost maxed, and then kind of like I did on the 1/4" material on the other side, I turned the wire feed speed down a little bit, and you can see, you know, the higher wire feed speed, it did result in a little bit larger weld, but not really a hotter one with any more penetration. Based on this here, I would say this machine is not up to the task for 3/16 material at all. And this is just, you know, a tiny little T-joint. You know, it's not, you know, I'm not trying to weld some large piece to something else. This is just a small little T-joint on the bench and almost no penetration. So, and actually on the vertical or on the horizontal section, really none at all. And keep in mind that is plugged into a 20 amp outlet with properly sized conductors in the wall and no extension cord. So this wasn't done with an extension cord or anything to where I was limiting power. I was plugged directly into the wall, getting as much out of it as I can. All right, so my overall opinion of the welder, as far as build quality, operation, and just, you know, the basic functioning of the welder, not too bad for the price. It is just about the cheapest you can get, and it does work. The included wire is not too bad, although unless you get the package deal with a second spool of wire, the amount of included wire that you get is pretty small. But the included wire did pretty good. I didn't have any issues with that. The included accessories are pretty cheap. The wire lengths are pretty short. You know, there's definitely some concessions for the price. If those were the only concessions for the price, I would say that this welder is a home run for the price. But the problem is, the other concession is that it's an AC welder. That's going to give you a little bit harsher arc. It's going to give you a lot more spatter. And I think, as we're seeing here from the cut and etch tests, it's going to give you a lot less penetration too. Because I did do some testing and some cut and etching with a Lincoln weld pack welder from Home Depot, and that welder is actually only rated at like 88 amps, whereas this one's rated at 125. And I got far more penetration with that welder, 1/8, 3/16, and even I think I even did 3/8 material, and I got more penetration than what I'm getting with this welder. So just something to keep in mind, that AC only output is going to result in a little bit more spatter, not as clean of a weld, not quite as smooth of an arc, and based on the cut and etch test, it's going to result in a lot less penetration. I would say for 1/8" material and under, it does work. I think you get enough penetration for an okay weld. The welds come out actually looking somewhat decent, so if you were to take a wire wheel or a flap disc or something, clean up the spatter, I think it would be a perfectly good looking weld. Again, on 1/8" material and down, probably fairly sound. But anything above that, and I would say it's an absolute no-go. So there you have my thoughts on the Forney Easy Weld 125FC. Hopefully this was interesting or helpful to you. Maybe if you're considering it, you have a little bit more idea what you're getting. If you have any questions, feel free to post them up down below. I'll answer if I can. As always, thank you very much for watching. Take care.